Okay, what is a constant of proportionality? I'm going to give you just the simple definition first, and then if that makes sense, please feel free to stop watching. And then after that, we're going to break down some of the terms in more depth. So the constant of proportionality is basically the ratio between two proportional quantities or shapes. There's the definition. Feel free to stop watching now. If not, I'm going to continue to break this down and explain it. So, a lot of the times we talk about the constant of proportionality in the context of similar triangles. So, first of all, what is a similar triangle? Similar triangles are kind of in the realm of congruent triangles, or I don't want to say contrasted, but those are kind of the two categories of triangles that we analyze frequently in geometry. So similar means same shape, and remember, angles give your triangle the shape. So it's basically all same angle measures, but they're going to be a different size. So they're going to have different side lengths. So they are going to either be bigger or smaller than the other triangle. Congruent triangles are exactly the same. So same shape, meaning all the same angles, and same size, meaning all the same side lengths. So let's look at an example here. These triangles are similar. We can tell because we see that all of the side lengths have been multiplied by the common ratio, which is what we're going to talk about now, and how to find the constant of proportionality. So when I look here, going from 5 to 10, what do I have to multiply? I have to multiply by 2. Going from 4 to 8, what do I have to multiply? I have to multiply by 2. Going from 3 to 6, what do I have to multiply? I have to multiply by 2. So I can see here that all of these side lengths have a common ratio because they're all being multiplied by exactly the same amount. So this is going to tell me that these triangles have exactly the same shape, and the constant of proportionality is 2. Okay, now let's go on to one more example. Here we go. So here's another example, same thing here. Actually, I'm going to show you how to check if these are similar triangles. So in this case, what I would do is I would actually take my corresponding side lengths and I would divide them to see if I get the same ratio each time. So 5 divided by 2.5 is 2, 4 divided by 2 is also 2, and then 3 divided by 1.5 is also 2. So because these are all 2, I've basically again proven that this triangle is 2 times as large as this triangle. However, if I'm going from this triangle to this triangle, I would be not multiplying by 2, I'm getting smaller, so I would be multiplying by a half. So I would actually say my constant of proportionality for, let's just call this, I don't know, let's just call this triangle A and let's call this triangle B. So my constant of proportionality going from triangle A to B would be 1/2, again, since I'm getting smaller.